Hi, I wanted to give a little more feedback on line of best fit, and I just found this really cool one, and I'll give you the link underneath this when I post it up there. It's kind of neat because as you start putting dots on, if I put all the dots along the same line, then it's a really strong positive linear correlation, and the R value would be close to 1. If I start to add dots kind of above and below, we can still be strong, but now we're getting to, I would probably say moderate before I went to weak, but moderate linear positive correlation. And then as I get really further apart, then I would get into saying it was weak positive. If I reset it, if I started my temptation down this, or my graph down this way, now we're getting to a weak negative because the trend is kind of going down, but it's not really close. None of the points are really close to the line of best fit. Is that all right? If I started putting dots that seem kind of random and there's no real note to them, then we're talking no correlation. We're not getting any kind of pattern of anything going up or down, so we can say no correlation. So it's really important to note that our options are strong negative. You can do a moderate to weak negative. I'd still say that's moderate before I said weak. Weak would be a little further apart. Alright, there's weak negative. Or we can have no correlation. Okay, there's no correlation. The dots just seem just kind of random. And then we can do the same thing for positive. Strong positive, the lines are right across the dot. As the dots sort of go either side of the line, we're going to go from this to moderate. I'd call that moderate first. And then as I got them a little further away, we're getting into the weak positive linear correlation. So it's important when you do your graphs to, these don't have any units that are relevant right here, but think about when you're doing your graphs in the assignment, what kind of units might go across the bottom. And almost always across the bottom is time, because time is the independent one. That's the one that happens no matter what, and then we're comparing after time what happens. So there's one where it has time along the bottom and free throws going up the side. There's one where it has time along the bottom and height going up the side. That's your question number 2. There's one where we've got time along the bottom and reaction time. And reaction time question is talking about, like, if you saw a red light and slammed on the brakes, how long between seeing the red light and slamming on the brakes, alright? So some people end up putting like 20 seconds, which I think would be a lot of accidents. So try and think about how long does it take. You see something and you react, and does it change when you're younger to when you're older? Same as the oven cooking temperature is the kind of weird one, though. That's the only time we're not going to put time along the bottom, because what we're going to do is we're going to say we're going to change the temperature along the bottom. That's going to be our independent variable, and then we're going to see how long it takes to cook a steak or a roast or whatever. And so that's the only time in your assignment where you're going to have along the bottom, you're going to have temperature, and along the vertical axis, based on the temperature, how long does it take something to happen. So that's the only weird one. Other than that, time's always going to be across the bottom. So hopefully that helps with your assignment.